Hello and welcome to the Argyle CIO Leadership Forum. My name is Vicki Limbrunskill with Argyle. It's great to have everyone joining us today. Just a couple of notes before I turn things over to our esteemed speaker for this session. First, a quick reminder to stop by our sponsors' virtual booths at any time during the event and for the following week. Our partners are committed to providing you with valuable content and a great overall experience today. And at any time during the event, you can visit those virtual booths from the main agenda page, and those do include complimentary materials, information, and meet and greet opportunities. Also, it's very important. We want to hear from you. So to ask questions throughout the session, simply type into the Q&A chat, and we will address your questions at the end of the session. And now, without further delay, I'd like to introduce our speaker, Sunil Joshi, CTO and Vice President, Hybrid Cloud Services Americas, and Generative AI Lead at IBM. We are so excited to have Sunil with us for a thought leadership presentation titled Unlocking the Power of Generative AI for Application Modernization, Real-World Use Cases, and Strategies for CIOs. Welcome, Sunil. Over to you.
Thank you so much, Nikki, for such a wonderful introduction. I'm so happy to talk about this topic today. I'm sure everybody is thinking of doing some form of modernization within their enterprises, especially given the landscape of hybrid cloud, AI, and everything in between. And so I wanted to take the time today to basically narrate my experiences, my challenges that I have seen, and trying to do this with many clients. So I'll start with some fundamentals. Now, the slide that you're seeing in terms of challenges, this is not holistic, but this is some directional, challenges that I have seen, and I've tried to categorize them in three buckets, but we can categorize them in multiple buckets. But the net is, while transformation, while modernization is a key element for many enterprises for a variety of different reasons, right? Better productivity, higher growth, opening new avenues of opportunities, faster time to market, cost reduction obviously is very imperative. There are so many different business drivers where organizations will try to modernize, transform. Application modernization specifically poses a very different sets of challenges that one has to take into account, and I'm going to articulate today how using some AI, Gen AI techniques in combination, I sometimes use them interchangeably, and I'll be very specific, can help mitigate some of these things. Right? There's newer ways of doing certain things that may have not existed maybe 18 months ago, 24 months ago, that can help us do this. So let's talk about a few challenges. One of the biggest things that I hear from our clients, especially when they're dealing with legacy applications, is lack of application knowledge. Some technologies are very ancient. I mean, I have been challenged to help folks modernize things like BASIC, Fortran, C++, even old school Java for that matter, right? So, um, uh, legacy, obviously also includes certain mainframe type technologies, cards applications. It could be a widespread. Not having a full depth of what all of the components, programs, submodules actually do is a huge challenge, especially given that many of the folks that have actually designed and maintained these applications for a very long time may have exited the workforce. Happens. Second thing is, especially in an enterprise which has accumulated an ecosystem of applications for very many years, either through mergers and acquisitions, um, either through a lot of upgradation but lack of rationalization, you're going to have very complex integration architecture. It is very difficult to decompose. It's very difficult to understand the dependencies. So it poses additional challenges. I called out technical debt specifically, even though we could say it's a sub bullet, it's fine. Everybody has technical debt. One might argue having a very small bit of technical debt is actually healthy, but the disproportionate amount of technical debt adds a lot of complexities for operational cost, operational challenges, but more importantly, becomes a little bit challenging cost prohibitive for modernization. I will not address every one of those. You can just read through it. The last one I will say is, what happens post modernization does become somebody else's business in many enterprises because the responsibilities may be in different organizations with different leadership. But not having a pathway to actually fully manage, fully modernize applications is a problem as well. So we need to look at next generation of operations as far as modernization is concerned. So now, having established some of the challenges, let's look at some opportunities with generative AI. So I took the prior list of challenges and basically laid out in like four verticals. And this actually show you sort of like the life cycle of modernization, life cycle of development, either ways you want to use it, right? The first two buckets talk about discovery, design, develop, test, deploy as a category, and some challenges there. And the next two bucket talks about platform engineering, which is basically setting up your environment, setting up your infrastructure as a code, any DevOps paradigms, as well as your operation engineering, and how generative AI and AI can actually help build a corpus of productivity and unlock some of the value faster. And then I've gone about giving some Gen AI solutions where things can work, etc., and some productivity measures, typical types of benefits that we are seeing. They're all very conservative. There's a lot more that can happen, right? So how do we go about identifying this? So I'll show you a really complicated view, which some people may jump out of the window but don't. It's just a view to actually start having a conversation. This is what I call as looking at the entire development or modernization lifecycle and trying to do like a value stream engineering and see where are all the different areas, whether a traditional AI or a generative AI models can actually play a part. And on the right hand side, I've taken the liberty of articulating some directionally correct use cases where we are seeing a lot of activity, um, uh, and productivity. So I'll just take a couple of examples. Now, how do I connect these to the challenges that I articulated? First challenge I said was lack of application knowledge. Okay. So under discovery today, what's happening, there are many foundational models that can actually go through legacy applications and reverse engineer them and get us English literature of what these applications actually do. Okay. So you can do that. There are two different things that I call them as system explainability, which basically takes the entire corpus of the system, understands what the system actually does, what the system context, which means interdependencies with other subsystems, whether it is internal or external API calls, other types of databases, etc. It'll basically articulate that, and then program level explainability, right? At every program level, source code level, it basically starts articulating the explanation of what it does, and it doesn't. Most of the time, it won't matter. Well, I guess it does matter, but it can be very legacy code. I've actually seen decent bit of explainability for all of the runtimes and the languages that I articulated earlier, right? So it is possible to get that kind of explanation on what it does. Now, what's the value of getting this explanation? Of course, we can read those and make some corroboration at least. Oh, I don't need to understand COBOL. I don't need to understand C++, but there is an English literature here that tells me what the program actually does. Second thing you can do, you can actually aggregate all of these types of explanations. You can actually, vectorize them, put it in a vector database, and actually have a chat interface on top, which basically means you're chatting with your code. What's the value of that? Let's just say you want to do some enhancement or modernization. I want to be able to enhance to create a download functionality for XYZ. You put that as a natural language. the expected behavior, because all the programs have been explained away in English and vectorized. The model should come back and say, okay, for this type of a functionality, here are the 4 potential programs you may need to go look and update. So that's acceleration, right? So we don't have to do extensive discovery. It's directionally telling us where to look for. Now you can extend the same argument for better management. Let's just say there is a incident, some bit of functionality is not working. You do the same natural language, then it will come back and suggest where to take the course of action, so on and so forth. So I can go on and explain away many of these numbers, but that's why it's good as a starting point of a conversation, within your own organizations, to take a look at some framework like that. I have a similar view for operations. Wherever you see the brain icon is where we think those types of capabilities is what is going to help from next generation of IT operations, mostly powered by a combination of traditional AI, generative AI. Give you one quick example. Um, Ingesting historical incident resolutions and using some traditional AI and generative AI techniques, when there is a challenging incident, you can immediately get, within a matter of seconds, what were all the prior similar issues that were resolved, how they were resolved, and using some generative AI techniques, automatically generate runbooks for resolving current issues. Now, you may choose to run it, you may choose to not run it, but at least you have a starting point of what that solution can be. And so, again, accelerated problem resolution. Yeah. Okay, so I'll give you a couple of real examples. What does it mean? In one of the aspects on my list was tech debt mitigation. Okay, here is a real example. We looked at a corpus of, this was for a specific client. They were, their Java applications were in Java 7, which is very, very ancient, right? And they wanted a pathway to get to Java 17, albeit Java 17 is not the most current, but that's where they want to get to. So before I investigated this, I think they had like a 28-month program plan to remediate 350 odd decently sized monolith Java applications to go to Java 17. By infusing generative AI, building some assistants, using these techniques to actually upgrade. And it's, when I say Java 17, let's not oversimplify. I mean, it's not just that version. This includes some of the frameworks that they use, like struts and hibernate and other types of things. So fairly complicated work. We were able to cut down 25% of the time, in terms of the overall program plan. So you may sit and wonder, 25% is not, it's a decent bit of acceleration. Because the promise of Gen AI is that it can do a lot more, which it can. It depends on additional scale. And I actually, since this was the very first time that we were doing, we spent quite a bit of time building those assistants, etc. Anyway, I wanted to give you a real life example on one of the problem statements I articulated in the first slide. I'll give you one more. So this slide is speaking to C++. I think the example will speak to COBOL, but the method remains. What I'm showing you here is multiple different patterns that you may want to think through when you're talking about modernization. There are going to be elements of your applications that may be conducive to a straight migration to a modern technology. If you're talking about header files, supporting classes, or batch programs, or things that don't have too much upstream, downstream dependency, self-contained type thing, may be conducive for doing a direct conversion. And most times it works. I would actually prefer true modernization for everything, but that may not be realistic in terms of economics. So I think that's a valid pattern. The second pattern is where the interdependencies are quite a bit, lots of business logic involved in certain applications. So the best way to do that is the technique that I already told you earlier. You reverse engineer those, you understand the corpus of what it does, you use other large language models to actually generate user stories, acceptance criteria, business rules extracted out of it, and then you use assistants and other large language models to then convert them, rewrite them into a modernized technology. I have seen better results with this technique than a straight conversion, especially with complex applications with a lot of business logic. And that's exactly what we did in this example of another case study. Um, so I'm only saying in this case GenAI powered discovery because this is an ongoing program. Um, but the entire discovery was infused with generative AI, and we are able to see total, I would say anywhere between 30-35% acceleration we have already gotten just at discovery. But you know, we were able to extract out business logic and functional requirements almost in half the time that was allocated from a program planning standpoint. So this includes, who are the personas that are influenced. In this case, product owners, scrum masters, some degree of solution architects. For these very, very legacy applications in COBOL, we were able to reverse engineer, extract out business rules, create functional specifications, user stories integrated to Jira, already pre-populated in Jira using some of the models. So a Scrum Master can just now come and validate what those user stories are and make some corrective actions so the next set of development activities can go on. So I just wanted to give you different flavors of examples of the types of acceleration that one can have, by using some of the traditional models as well as generative AI. Okay, so what next? I'm summarizing this here. So before I do that, what I want to do is now quickly pivot. I'm going to show you a quick demonstration that might actually be a little bit more useful than what I've been sharing so far. So I'm going to share separately. Okay, so what I'm going to share right now is actually a demonstration of how we can take a very legacy. I could have taken any example, but I am picking a monolith Java application. It's a banking application. And using some of the AI and generative AI techniques, I'm going to show you how we can decompose this into smaller consumable services and create a modern microservices architecture based implementation, and then provide a pathway for automatically being deployed. It could go to any hyperscaler of your choice, any cloud, or even a Kubernetes cluster on-prem if you so choose to, right? So I have skipped all the discovery part. Where we begin is where we ingest a Java file, which I'll show you as is fairly complicated. So you can see it's not a very simple application. It's pretty large. It's a monolith. And then let me pause. You can see the breadcrumbs here, right? What we are trying to do, I want to extract business rules from it as a first step. And I'm calling a specific LLM agent in the background. The generative AI is actually helping me do that. After I extract the business rule, I'm going to call some other agent, which may be using a completely different model, and then to create open API specifications for those rules. So then if I have this, I have a pathway to actually implement each of these APIs as microservices. And there are other techniques to doing that, but I just want to show you that part in this demonstration. Okay, let's run this, and you can see very quickly as soon as I invoke the model, you can see real time the business rules are being extracted out of this specific Java application that I'm interested in. Yeah, let it run, and let's see what happens next. As soon as these rules are extracted out, now I can take this, I can download this into a different format and choose to do other things. But I do want to show you now. Let me pause it for a second. Typically, what happens in a life cycle like this, while I'm showing the end-to-end journey over here, there is typically a human element involved. because the extracted business rule may not be 100%. And I'm not going to sit here and lie about it and say everything is a full magic here. There is no magic here, right? What there is a true bit of productivity and acceleration. So we may have to validate what the application actually did. Sometimes the product owner needs to be involved, making sure, hey, do we have all the rules captured? Do we need to change a few things? Sometimes some of the models will actually also uh, create some technical rules because of the way the Java or any other program may have been implemented, and which may not be meaningful as part of a user story or a specification that we are going to create. So there is this element of human validation that is necessary, which I'm skipping in this case because it was a fairly uh, simple in that regard, the rules that I've generated. So let's take a look at next. So there is another agent that was invoked, and this is actually creating now. Whoever, if any of you are familiar with what OpenAPI specs looks like, this is a very structured, standard, engineered OpenAPI specification. An OpenAPI spec can then be used to actually implement APIs and microservices on any API management tool of your choice. That gives you the flexibility to download. You can actually create Swagger definitions or RAML definitions, other types of formats um, that can be ingested for further processing, such as creation of microservices. In the interest of time, I'm going to fast forward all this and show you the last part where I am going to pick a specific framework. In this case, we are going to pick a Java Spring, I think. So let's just run this. So you see the YAML file was the that we are ingesting here is the API specification that was created in the prior step. And looks like in this case, we are actually trying to create the microservice and actually push it to AWS because I can see some AWS infrastructure and infrastructure as a code being configured. There's all the configurations. I'm just going to pause it right here. What I wanted to show you is you can pay attention, forget the right hand side, but just look at the left hand side, right? This is an end-to-end journey. Once the specification is provided, the ability to actually construct Java code, create some of the adapters, create the CI/CD pipes, build the infrastructure, and actually, plug in the monitoring aspects, plug in the observability within the code, and then actually deploy it to a specific hyperscaler. I hope the power of AI and generative AI in concert with additional automation um, can actually greatly influence how we think about application modernization and platform modernization in that regard. So I can give additional examples, but let me net it out in terms of what I spoke about in the last 22 odd minutes. I started off with a set of challenges, and that's going to be mostly applicable to any medium, large sized businesses. For each of those challenges, there are mitigation circumstances today because of generative AI, traditional AI, extreme automation, all playing a part. Some of the things that we talked about, lack of application knowledge, can be solved through creation of application management repositories, building chat interfaces, stitching models together to help with that. Technical debt. I gave you some very specific examples of how Gen AI models are helping resolve for technical debt with good bit of acceleration. When I say acceleration, it's basically time savings and cost savings. Now you can redirect that saved cost for additional types of transformation or upskilling your employees, etc., which may otherwise not have been available. Another classic example that we have seen, especially with modernization and migration programs, that becomes challenging is improper sequencing of applications to migrate or modernize. So I have seen places where people end up with a transaction that starts in a hyperscaler, flows back on-prem, flows back for doing some type of processing onto a cloud, comes back to fetch some other data. You want to avoid that kind of chatter, you know, for performance considerations, for sustainability considerations, ease of operations, etc. By using deeper generative AI based discovery, we can actually get ahead of this, do proper discovery, and influence proper sequencing and program planning. So the chances of success for our modernization programs will be a lot better. The last one I will say is better IT operations, um, all the way from the knowledge management corpus that we already talked about. Auto generation of runbooks is an example that I gave you earlier. Elsewhere, we have implemented some AI models that actually can do the step zero of any incident, which is basically categorizing the incidents properly and actually transferring that over to the right resolver group. As simple as it sounds, many enterprises have 20-25% failed or breaches the SLA for incidents because they were redirected to the wrong resolver group. So I'm going to pause here. I know we have only about 3 or 4 minutes left. Let's see if you have any questions. I'm going to go to the chat here and see if I can pick a couple of questions to answer. Question: given the potential of Gen AI to revolutionize app mod and maintenance, can you elaborate more on how organization can integrate a genuinely holistic and efficient software delivery lifecycle? I will point you back to that really scary slide that I had. In that, we can look at every aspect of SDLC. There are assistants that can be created for discovery, for user story generation, test case generation, even before a line of code is ever written. Code creation and code generation, of course, is a very popular use case. We can build Gen AI assistants for creating deployment scripts, for creating release management notes, and better management, obviously, from an operations side as well. Another question: usually when it comes to impact of Gen AI for app mod, is the inability to smoothly integrate Gen AI can lead to siloed applications, limited functionality. It's rather a long question. Let me see what the net is. This can hinder the potential benefits of Gen AI, such as automating process, business insights. What's your take on it? Okay, it's a very broad question. It's very difficult to answer in a succinct way, but let me attempt it, right? I don't think generative AI is going to be all and all, right? What we can do is decompose the problem end to end and see in each of these decomposed areas of modernization where we can infuse generative AI, where there is technical viability and economical viability. We don't want to use things just for the sake of using, right? Where we are using this, at least in the app mod, is for acceleration and productivity. So there are very specific use cases where we already know there is value to be had. And the integration aspects of program planning and the architecture should still happen. I don't think there is, we are saying skip that process. You still have to do that, but there is a good bit of acceleration that can be had by infusing this. One more. What are the primary challenges one might face when modernizing legacy systems, and how can Gen AI assist in overcoming these challenges? I think I showed you the challenges and some solutions as well. I can tell you a couple of additional challenges specifically for using large language models. There is always the challenge about do you trust the data, or can you infuse enterprise context into some of the large language models? I have to say, some of the foundational models, especially with um, support models exist, whether it is Granite or other vendors that have built this, are getting very smart by the day. I think there are techniques now to actually also ingest enterprise context, so the code generated or the test cases generated actually reflect the realities of your organization. So I think these are all coming, and there is going to be a lot more applicability of these assets and assistants as we go on. So with that, Vicky, I'm going to hand it back to you to close.
you so much, Sunil. What a great presentation. I'm sure there's going to be lots of questions coming your way. I wanted to thank everyone for joining us for this session. This session, along with all of today's content, will be available on demand following the event. Our next session will begin at 2:05 p.m. Eastern Time, and that'll be a thought leadership titled Proven Technology Imperatives for the Modern Business. Please click the join button that will appear on your screen to be redirected to that session. We look forward to seeing you there. Thank you again, Sunil.
Thank you.